Before we get into the examples, there's one more thing I want to talk about. You'll need to put this on a separate sheet of paper instead of the little half sheet that you just saw in the previous bit. Okay? Which is this. What's called the nth root. Okay? And what that means is that for any numbers, let me write that. Numbers A and B and any positive integers, sorry, n, if A is to the nth power, n being an exponent here, okay, then A is the nth root of B. What in the heck is that trying to say? What it's trying to say is this. Since 2 cubed is 8, we can all agree to that. 2 is the cube root of 8. Okay? Meaning that we write it in this notation, which is the cube root. I'll rewrite that. The cube root of 8, which equals 2. So what, in other words, this means is that the area of what you've known as the square root has now finally exited. We are no longer bound by the invisible 2. We can make the root whatever we want. 3, 4, 5, 6, 10, 20, 1,000. Okay? It does not matter. So what we'll learn about later on, we're going to learn something else, how we call it the radical. We'll learn that word's going to show up more and more and more as we go further into this unit. But for right now, all I want you to focus on is that the square root can be a cube root, a fourth root, a fifth root, and so on, okay? It's no longer bound. Unless it specifically says, however, that it is a certain type of root, it'll always assume to be 2, meaning they have to put the number in front of that root symbol, okay? There has to be a number here. If there isn't, it's a square root, okay? I would, in fact, maybe even write that down, okay? Unless there is a number for the root, then assume it is always 2, aka a square root, okay? Now, let's take a look at some examples. Don't worry, I'll leave this up there so you can see it. Okay? Number 1. Obviously, some of these are going to be easy. The square root of 16 is obviously 4. Square root of 64 is 8, right? But here's the thing. Whenever you take the square root of a number, you're actually getting 2 answers. Technically, that's wrong. When I say the square root of 64, I'm actually getting plus or minus 8. Why is that? Well, the reason why has to do, okay, with how 64 works, or how any perfect square works. Because even though it can be plus 8 or minus 8 or negative 8, that's because I can do negative 8 squared and get 64, and I could do 8 squared and get 64, because the negative is essentially implied, albeit relatively clunkily, that's a word, okay, but it's implied, okay, which means that whenever you do the square root of 64, you will actually get 2 answers, which actually makes sense given squares. A quadratic is a square, right? Because it has x squared in it. there are two answers, two roots. The same thing holds here true. Sometimes with quadratics, however, sometimes they're positive, negative, sometimes negative, negative, sometimes they're both positive. With square roots, they're always one negative and one positive. Okay? Unless it's not a perfect square. For all intents and purposes at this level, yeah. Okay? Number 3. Okay, so now that we have that in mind, what about a fraction? What if I had 4 over 25? Don't panic. It's actually really simple. Much like how whenever you do an operation to a fraction, you do it to the top and the bottom, same thing applies to radicals. What this is actually saying is a square root of 4 over the square root of 25. And those are both perfect squares, which gives me 2/5. And yes, it would be plus or minus 2/5, but for simplicity reasons, I'm going to write the symbols. But it's just 2/5. You split the square root between the two parts, the denominator and the numerator. All right. Number 4. Okay. What about if we had negative square root of 121? Now, there's just an invisible negative 1 up here. So realistically, all this is negative 11. Okay. What about decimals? What if I had the square root of 0.49? Oh my God, the calamity. Don't panic. First of all, you can undo decimal points temporarily. What do I mean by that? I can take 49, or 0.49, and move it over 2. So that now I'm taking the square root of 49. Well, I know what that is. That's the square root of 7. But that isn't my final answer. I need to move the decimal point back over. Oh, sorry, it's not the square root of 7. It's just 7. I'll just cross that out. So then you get 7. So you need to move the decimal point back over. 1, 2. So your actual answer is 0.07. Okay? So long as you have perfect square numbers, it doesn't matter if they're in a fraction, if they have decimals around them. None of that matters. Okay? Just manipulate a little bit so that way you can see it, or don't at all. Say, oh, it's 0.49, 0.07. Okay? You'll get better at this the more you practice it when you start to pick up on the little idiosyncrasies that come in this problem. Right? Now, here's the more popular one, right? Here's a couple other funky ones. Let's say, for example, I have the square root of negative 12 squared. Okay? The square root of a square cancels the squares. The reason why is because of this. If I rewrite this, and this is where it breaks a lot of people's brains, so please pay attention. Square roots, and any root for that matter, can be rewritten as an exponential fraction. Does that make sense? Okay? Meaning that if I have the cube root, it'd be 1/3 to the power of 1/3. If I had the fourth root, it'd be to the power of 1/4. Okay? So, but here's the thing. A power to a power multiplies the fractions. So you have negative 12, 2 over 2, which becomes negative 12 to the first, which is just negative 12. That's why square roots cancel when you square a number. Okay? Sorry, yeah. Okay? Because it's a perfect square. If I had the square root of 25, well, I can rewrite it as 5 is 5 to the second power. Square and 1/2 cancel. Done. That's why that works. That's why they're called perfect squares. Okay? So when you square root a square, be it a number, a variable, which we'll talk more about those tomorrow, or not tomorrow because we won't hear yours tomorrow, but the savings time. Yep. They haven't pushed the clocks back on the bells. Yeah, for those watching at home, don't worry about it. Okay, so we got that. Now, number 8, however, what happens if I drop those parentheses? Ladies and gentlemen, it's no solution. Exactly, because we can't take the square of a negative number. Remember, that -1 is a coefficient in front of 12. It's just negative. 12 squared is 144. It's still negative, so it's not a perfect square. So don't think you can just simplify the 12 and then square root it. You can't get rid of that negative unless it is included in the parentheses. Then you're okay. But the minute you open that jar, sorry, all bets are off. That also holds true for cube roots. If I had the cube root of -8, no solution. Okay? Speaking of cube roots, let's take a look at a cube root. What if I had, we'll come down here, number 10. What if I had the cube root of 64? Well, let's split 64 up. We got 8 and 8. We've got 2 and 4, 2 and 2, 2 and 4, 2 and 2. There's 1, 2, 3. 1, 2, 3. Haha. Okay. So that means that it's going to be 4 is my answer. Okay, because it's 2 and 2. You have 2 of them here. They're multiplied together and they come out because they're both going to be multiplied. Okay. Let's see. Let's keep going. What about number 11? Let's do the fourth root of 81. Okay. So we'll do 9 and 9, 3 and 3, 3 and 3, 1, 2, 3, 4. 3 is my answer. Yes, it does. Just because they come off of different pairs, you could still group them. It's perfectly fine because they're contained inside the number. Number 12. What about the fifth root of 32? I'm just going to give you a spoiler on that one. It's just 2. 32 splits into 8 and 4. 4 splits into 2 and 2. 8 splits into 2 and 4. 4 splits into 2 and 2. 1, 2, 3, 4, 5. Done. Did it in my head. Okay. So I think you get the idea at this point. All right. So hopefully those examples helped, as well as that explanation involving the nth root.